Good morning. My name is Jeff Goad. I'm Vice President of Polyurethanes for Rubberlite Incorporated. I'm going to give a brief talk about our HyPUR-cel polyurethane line. I'm joined by our product manager, Kevin Ross, and our tech service manager, Ryan Cooper. So, HyPUR-cel. So HyPUR-cel, many of you out there I see know HyPUR-cel as a product line of HyPUR-cel or of polyurethane materials. But what it actually is, it's a technology platform that allows us to make a portfolio of polyurethane foams. It includes formulation strategies, process conditions, nucleation methods, and operating disciplines, all that allow us to manufacture foams that provide a solution-based approach for design engineers to optimize function, performance, and cost in their designs. So HyPUR-cel Technology, yes, is a series of polyurethane foams, but it's also a process. Plant assets, a specific design in the way we process, and a specific operating method. All intellectual property to Rubberlite. But more importantly, it's a set of polyurethane capabilities in which we do design and development and then new commercial implementation. So what are those capabilities, polyurethane capabilities? Well, it starts with the chemistry. So in-house in Rubberlite, we do our own chemistry. It's polymer science, it's formulation sciences, and then it's our own catalysis and surfactant work to optimize for each of the materials that we make. So these two guys pictured in the photo, Mike Dimitrov and Jamie Durham, they are seasoned veterans in the polyurethane industry, and they are part of Rubberlite and invent materials every year. In addition, engineering is a very important part of this. We have all in-house engineering. So that starts with process engineering, process automation, run plant engineering, and the physical plant. Here you see Jessica Spurlock and Jacob Beers. Jessica's our process automation engineer, a very talented person who's converted the plant to all Allen Bradley through a supervisory control system so that we have a data historian that tracks everything we do. It's a significant part of our process. Jacob Beers was an intern for us, and we hired him on as a new run plant engineer for the HyPUR-cel process. And then thirdly, Rubberlite has an A2LA accredited laboratory to do all the characterizations. We do performance characterizations and performance characterizations for every lot of material that leaves our plant. It is critical to our customers to understand exactly what they're getting and the consistency of the product. Ryan runs that part of the organization, and part of what we generate is a product, but we also generate the data that follows that product cradle to grave. So here, in the spirit of March Madness, I'm going to talk about our product line as an overview. So we offer V series in HyPUR-cel, S series, I series, T series, and our most newest launch, R series. So what's the significance of this bouncing ball? So what we're really showing here is the range of viscoelastic to high resiliency materials that we cover through our HyPUR-cel product line. So it's a technology that allows us to formulate and engineer foams throughout that spectrum. So let's discuss very briefly what that means. So in terms of viscoelastic, so here you see a plot. This is a hysteresis plot where we're measuring the load against a material. Sorry, I've lost my microphone. Sorry, microphone went off. So here you can see we're measuring hysteresis loss. And if you look at a viscoelastic material, as you watch what's called the load curve, as you're either compressing or stretching material, you're putting a load on it and it's responding to it. You'll get a curve that looks something like that. But then when you return or unload that material at that same rate, you'll get a curve that looks like this. This is an example of what a viscoelastic high hysteresis loss material gives you. What does that mean? That means it's absorbing energy. It's absorbing energy and converting it to something, and that is heat. So that is one end of the spectrum. The other end of the spectrum is high resiliency. So you have a load curve. Well, I cheated on that one. So you see the load curve goes up, the unload curve comes down, and you're looking at the area between those two curves that defines the hysteresis loss. You can see in a highly resilient material, what's it doing? It's returning that energy. It's not dissipated into heat. So the area between those curves is very small. So in foams, that is a complicated subject because you have both composition and geometry. You've got a cell structure. For instance, a closed cell material can trick you into thinking it's high resilient, but it's that pneumatic effect of the air in the cells that's giving you that resiliency. Here in an open cell foam, which HyPUR-cel polyurethanes all open cell, you're going to have a durable product with a highly resilient return of energy. So the key to our technology is that we have these bookends of the range of materials that you can make from a materials science perspective, and then we can make anything in between there. So what is meant by a series? You see I said V series, S series, I series. So what we do is we take a chemistry, that the S means a certain chemistry, and then if you'll see here, I have density on the x-axis and compression, deflection, and PSI on the y-axis. So for any given formulation, I can make a full range of densities with our technology. And then for each density, CD responds proportionally, right? So I can take that same formulation, make a few minor adjustments, not in the qualitative contents of that, but merely subtle adjustments to quantities and process conditions. And I can make a different curve. So now I've got a whole different profile of densities and resulting firmness materials. And then I can take that same material and do it again. So this is a very responsive curve. So here's a soft material, same concept. So now what we do is, by understanding the relationships there and what we've done, we develop some compositional models, and we can predict both the physical and performance characteristics of anything inside of those curves with a very high confidence interval. So we can, and that's why we say in our literature that we custom engineer foams, because we work under a simple premise that we're going to model what we make, and we'll take those empirical models and we can predict what you need, what the customer needs. Another example would be our I series, one of our newer versions, an industrial version. You'll see the same curve. It's density on the x-axis, compression deflection on the y-axis. And with a single composition, I can make this range of densities. Now let me cover our nomenclature very briefly. You'll see that these points are labeled. These are points on that curve. The I tells you what chemistry it is. The first two, the next two digits, like the 0.5 here, that tells you the density in pounds per cubic foot. And then the last two digits tells you the compression deflection in PSI. So you can see that we have a range of 5 pounds per cubic foot up to 20 pounds per cubic foot. Just in this curve alone, there are more products up here, but we just didn't include them on the curve. And then we have a range of firmness that goes from 3 PSI to 18 PSI. Now I take that same chemistry, move the molecules around a little bit, change the process conditions, And now we have a very firm product. Now you see I can make a material that's as hard as 60 psi compression deflection at a nominal density of about 25. Gives you a broad range of application opportunities for with the same technology, the same chemistry. So it protects you in terms of things like product stewardship and durability and market exposure. We call this spatial mapping. So when you understand the empirical models, you can predict most of what you're going to make for new opportunities. So since HyPUR-cel is a free rise pour and we skive it, and because we do that, and because we have this vast range of densities and firmness options, we really can provide the broadest range of density, firmness, and thickness in the marketplace for polyurethanes. We're not constrained by the thickness and firmness or the density in the pour. That's all done after the fact. And then that same technology facilitates us designing specific to an application. We can, if we have two products, but the application needs something in between there, we can very quickly predict what that should be, make it, and hand it out for market testing. So covering some of the specific applications of our materials. Let's start with S-Series. S-Series is Rubberlite's flagship polyurethane material. It's exported from the United States to China, Indonesia, Malaysia, Europe, Australia. It's one of the few polyurethane products that probably leaves this country and goes to all those places. And it does that for a reason. It's an extraordinary product. So it's used in a lot of orthopedic applications or in applications where you need a high level of toughness, tensile and stretch properties, and elastic compression. So you can see behind me, we've got a machine that is stretching material, this orange material. So that is our S-Series being stretched. So this machine tests cyclic compression fatigue. So it's going to stretch that material thousands of times, and then Ryan's going to take it to the lab and he's going to test it. So he's going to test the dimensional stability, the performance characteristics over that thousands of cycles of stretch. And we can tell you the S-Series is the best in the game for these materials. You can see that some of the pictures were in orthopedic wraps, in strapping for, let's say, that's a sleep apnea mask, but there's many strap applications. And then because it is a polyester-based material, it has a lot of toughness. It's used in very industrial type applications. So don't let that fool you. It's a workhorse from an industrial perspective as well. I have 3 minutes left. Okay. V-Series. Viscoelastic energy absorbing, so great for impact absorption, vibration attenuation, and comfort padding. You can see it's used in padding straps, tactical gear, lots of applications where you have to absorb energy and not return it to the person that's wearing it or to the piece of equipment that's you don't want it to affect. Used in industrial applications as well to protect like circuit boards. I-Series, our general industrial performance material, has excellent elevated temperature compression set resistance, which makes it ideal for automotive applications. It is, what's the GM spec for?
GMW 16750.
So it's listed for GM interior applications. Excellent for industrial tapes, performance insoles. It's a general use polyether-based material. And then R-Series is one of our newest and most innovative products in which we're making an extremely high resiliency material with very novel chemistry. So in the other machine, you'll see that we're compressing a material. So R-Series is exemplary for resisting cyclic compression fatigue. You can cycle it hundreds of thousands of times. It won't lose its dimension. It's dimensionally stable. It won't lose its firmness. And it will maintain that compression set so that it is a performance material, ideal for high performance insoles, responsive dynamic applications such as dye ejection or flexographic printing. And now, very quickly, I want to talk about our supply chain. Supply chain to Rubberlite is not just buying raw materials. We have outstanding partnerships with our suppliers, and that's really what makes us who we are in terms of polyurethanes. We depend on our suppliers for many things: technical collaborations, innovation, really short-term turnaround on delivery of materials and manufacturing of our polymers, and then long-term planning, both strategic and simply supply of materials. And then they help us manage risk to our customers. So I can't say enough about the great thing that the suppliers I see in the audience here do for Rubberlite. It's part of our nature and part of the company culture to be in informal partnerships with these suppliers, and we can't say enough how much we appreciate you guys. So in that, with all we do, we're ensuring the sustainability of this technology for a long time in the company. And with that, product stewardship, a critical issue now for polyurethane foams. We depend on our suppliers quite a bit to do that, but we have a lot of in-house expertise in that area. And if you haven't been exposed to all the new product stewardship issues facing polyurethanes, well, there's a whole plethora of answers you got to come up with for when you're sending materials across the globe. And they just come at you one at a time and very fast. So that concludes this demo and this product showcase. I invite you to come into our booth, take a look at some of the posters. We've got product literature here, but there's more of some white paper technical posters here to explain some of the materials a little more in detail than what I've covered here. There are sample materials you can get your hands on, and then talk to some of the sales folks and technical folks here to get an idea of what materials may fit your application. And you could also talk to some of the folks about technologies that are still in the pipeline and will be launching soon. So thank you very much.